All right, let's get right into it. We've got a really fascinating and honestly a pretty urgent problem to unpack today. It sits right at the corner of aging, medicine, and AI. It's a kind of silent mystery, and you and we're going to solve it together.
So check this out. This isn't just a made-up story. It's a real case, and it tells you everything you need to know. Now, you'd think a heart attack would be obvious, right? Like crushing chest pain, all the classic signs you see in movies. But for this man, it was just a whisper. And this isn't some one-off thing. This case is the central clue in our whole investigation.
And that right there, that's the central question we're tackling. Why do these huge, life-threatening diseases sometimes just whisper in older adults? I mean, it's a super important question because if you can't hear that whisper, you can't step in to help. So, let's figure out why.
To crack this case, we've got to start at the very beginning, with the basic biology of aging. See, the secret isn't actually in the disease, it's in the body that the disease is happening in.
And this is the absolute key takeaway. A heart attack is still a heart attack. Pneumonia is still pneumonia. The disease itself hasn't changed. What's changed is the stage it's playing on, the older body. That's the huge mental shift we need to make to understand this.
Okay, so first things first, we need to be really clear about two different kinds of aging. On one hand, you have what's called normal aging. The sciencey term is senescence. And on the other, you have pathological aging, which is just aging plus a bunch of specific diseases. For now, let's just focus on that first one.
So what is senescence? Well, it's basically what happens to every single one of us. It's just the slow, predictable process of getting older. It's like the gentle, steady wear and tear on a car that you've been driving for years. It happens even if you never get into an accident.
And this leads to the single most important consequence of aging, something called a flattening of reserve. And I love this phone battery analogy because it makes so much sense. Think about it. When you're 20, your phone battery, your body, charges all the way up to 100%. A little cold might drain it by, say, 10%. No big deal. But what if you're 80? Now maybe your battery only charges to 40%. That same little cold now wipes out half your available power. It leaves you totally drained, totally vulnerable.
Okay, so quick recap. Older bodies have less in the tank. They have less reserve. So what does that mean? How does that actually change the way diseases look and feel?
Well, what it creates is something called the whispering phenotype. And this classic car analogy is just perfect. In a brand new car, if something's wrong, bam, a big bright warning light comes on. You can't miss it. But in a classic car, right, one from the 60s, a major engine problem might just be a tiny rattle you've never heard before. Only a real expert would pick up on it. And that's exactly what's happening in an aging body.
So these whispers, these subtle rattles, they often show up as something called geriatric syndromes. And what's so wild about these is that they aren't your typical diseases. They're not caused by one germ or one specific organ going haywire. Nope. They're the result of a bunch of different body systems all declining just a little bit, all at the same time.
And these are the heavy hitters. You see falls on this list and you think, oh, someone tripped. But in an older person, a fall could actually be the first sign of something like a urinary tract infection. Or delirium, that's sudden confusion. That could be the only sign of pneumonia, or even a heart attack. These are the whispers. These are the subtle rattles that are pointing to a much bigger problem under the hood. Okay, so we've got these really subtle symptoms, these complex syndromes. You'd think this is a perfect job for technology, for AI, right, to help us spot these things? Well, yeah, about that. It turns out that most of the AI we use in medicine today is, frankly, just not built for this. So to understand why, let's just take a step back and think about how doctors actually make a diagnosis. They're like detectives, right? They're not looking at one single clue. A fever by itself doesn't tell you much. It's all about recognizing a pattern. They have to connect all the dots, what the patient is saying, what they see during an exam, the lab results, and pull it all together into one story that makes sense. And here's the problem. Most of the AI we have now, it doesn't think like a detective. It acts more like a cheap smoke alarm. It's usually been trained on data from younger people, and it's just looking for one big signal. It's waiting for a single number to cross a really obvious line, like a fever breaking 38 degrees. But what if the fire is just smoldering? What if it's not making a lot of smoke?
This table just nails the difference. On the left, you've got the naive model. That's our smoke alarm. It's totally threshold-based. If the temperature isn't over 38, it says, nope, nothing to see here, even while a crisis is brewing. But on the right, you've got the geriatric aware model. That's the detective. It's pattern-based. It's not looking for one big clue.
It sees a bunch of little things. The heart rate is creeping up, there's a bit of new confusion, and it puts those clues together. It's looking at the trend over 24 hours, not just one single moment in time. It's a whole different game.
So clearly the smoke alarm approach isn't going to cut it. We need to build the detective. So what does that smarter, wiser AI actually look like?
So take a look at this. This is a mock-up of what one of these geriatric-aware AI dashboards could look like. And notice the most important thing. It doesn't just scream high risk in big red letters. That's what we call a black box. You don't know why it's worried. This is different. This says, hey, I'm worried about delirium or a fall, and this is the crucial part, it shows you why. It lists out the top contributors. It's basically saying, hey doc, here are the clues I found. What do you think? It's not a replacement for a doctor, it's a partner.
And to be that good of a detective, the AI has to pull clues from literally everywhere. Yeah, it looks at the electronic health record, the official stuff, but it's also pulling in real-time data from a wearable, like a smartwatch. It's looking at medical images, it's even factoring in cognitive tests. It's pulling all these different threads together to weave one single, complete picture of the patient.
So why is this so incredibly important? Why does this matter right now? Well, it's because of this number. 1 in 6. This isn't some tiny niche issue we're talking about. By the year 2050, 1 out of every 6 people on Earth will be over 65. People call it the silver tsunami. It's a huge global shift, and we absolutely have to have medical tools that are actually designed for the reality of an aging population.
And that's really where we'll leave it. Look, building an AI that's smarter, that can just crunch more data faster, that's amazing, but it's not enough. The real challenge, the thing we've been digging into here, is how do we make our AI wiser? How do we build an AI that gets context, that understands nuance? An AI that can tell the difference between a blaring fire alarm and a deadly, quiet whisper. That's the future of medicine we really need to be building.